Hi again. Trying to update you now with how to calculate and size the transfer lines on your ship. So the transfer lines would be the lines that move the fuel around the ship. So that means the pipe sizes that move fuel from the storage tanks over to the settling tank. Okay, in the manifold that we drew on our diagrammatic yesterday, there's the manifold, and these pipes that are coming off right here, these are the pipes we're trying to size. Now, generally, these pipes are sized based on how quickly you're filling up the settling tank. So these pipes and the pipes to the pumps typically are similar in size. So just to reiterate some things from the previous video, the settling tank that I'm going to use, the size of it is 42 meters cubed, and the time to fill the settling tank from completely empty is approximately 2 hours. So what I've done here is I'm going to come up with a Q value. Remember, for most of the sizing that we do for piping, we typically use this formula, Q equals VA, okay? So before I get into that, I just want to reiterate that the fuel I'm using for my application is heavy fuel oil, and this V value, the velocities, are on the suction side 1.8 meters per second, and on the discharge side, it's 4.6 meters per second. So when you're doing these calculations, you can do the calculations for both variables and pick the larger of the two sizes. I will tell you in advance that normally we only just calculate for the smaller velocity because that will give us the larger size, okay? So based on that, now we'll begin our calculation. And to come up with this Q value for these sizes, and come up with basically our pump size, I'm going to go Q is equal to the total size of my tank, so 42 meters cubed, and I'm going to divide that by 2 hours to give me my value. And in my case, my value is going to be, where's my fluid value? 21 meters cubed per hour, okay? So please just confirm with your own calculations that you're getting this number. So once I have Q, I now can also determine what my V is, and in the event I'm looking for A. So in this particular case, I got 21 meters cubed per hour, and that is going to equal 1.8 meters per second. But remember, I'm hours and seconds, so I'm going to multiply this by 3,600 seconds in an hour. Okay, and then of course seconds gets rid of it, and that is going to be equal to A. So when I calculate now and I transpose my equation to come up with A, I've got 21 over, and that's meters cubed per hour, over 6480 is my meters per hour is my velocity, okay? So the value that I calculate for that comes out to 0.00324 meters squared, okay, because we're looking at an area. And keep in mind, meters is the value used here. We generally size pipes in millimeters, so we got to do some conversion. So again, landing on the typical equation that A is equal to pi d squared over 4. I transpose that to be D equals the square root of 4 times A, all divided by pi. And now what I'm going to do is calculate for D, which is square root of 4 times 0.00324. And all that's divided by pi. And I come out with a value for D being 0.064 meters. Now, of course, I want to put that in millimeters, so I'm going to say that D is equal to is going to be, move the decimal 3 places, and we're looking at 64.0 point something millimeters. Okay, so now when I've got that value for my transfer line, I can't use 64. I'm actually looking for a nominal pipe size. Okay, so my nominal pipe size takes me back to using a pipe chart. All right, and I know you guys have this online, and I apologize that it's a little small. I'll try and hold it up. So when you're looking for a pipe size, we are looking for a nominal size. Keep in mind the nominal sizes are given on this setup, okay? So I'm looking in the direction of 65 and possibly 80. So when I look at 65 millimeter nominal pipe size, I read across to the standard, which is Schedule 40, and I'm looking in this last column as to what is the inside diameter. I need to get close to 64. In this particular case, I'm seeing 62.68. I'm not sure if you guys can see this on this video, but you should be able to see it directly online. So in moving down to the next pipe size, I see that nominal pipe size 80 millimeters has an ID of 77.92 at standard or Schedule 40 pipe size. Okay, this exceeds my value that I needed, so this would be acceptable. So for this particular scenario, I could use a nominal pipe size of 80. So anywhere where I have my pipe sizes, I would now put in the number 80. Please keep in mind, ladies and gentlemen, that if you have junctions like this, it is advantageous to put in the pipe size twice. It's very difficult sometimes for someone to follow through, especially if you've got long pipelines. Anyway, I hope that is useful for you, and I hope the calculations are becoming a little more straightforward. Not difficult math by any stretch of the imagination once you've got your values. So keep in mind your fluid velocities. If you're doing this for diesel fuel, your diesel values are a little different. And you would be looking once again at this particular chart and looking at the values down here for diesel oil suction and discharge. Anyway, I hope that's good, and I'll look forward to seeing your work.